Integrated Step-Down Power Solutions by Texas Instruments. This training module will introduce TI's Integrated Step-Down Power Solutions and overview TPS84260 and TPS82671 Power Management Integrated Circuits for point-of-load designs that raise the bar for size, power density, and performance. The challenge of power management requirements for telecom equipment continues to grow. The power management part requires higher energy efficiency, greater power density, and flexible power control. Typically at 97%, a 1% efficiency improvement reduces power dissipation by 33%. Reducing the power dissipation for a circuit by 33% reduces the cooling cost by 33%. This is important to ease the design of heat management. Higher density power solutions provide more room for application circuits, reducing the overall size of the solution. Future target is to achieve a power density greater than 60 watts per cube centimeter. Communication, improved system power management, increases efficiency and response across all operational modes. Portable applications are continually driven to increase battery life and reduce size. Analog circuitry and ultra-low power multi-control units often reside on the same circuit board, each having their own particular power requirements. This will increase the complexity of power management design. Texas Instrument Power Management Integrated Circuit Solutions range from standard ICs to integrated power solutions, including plug-in power modules, digital power, battery management, and high-performance MOSFETs. From isolated AC to DC and DC to DC power supply controllers and non-isolated voltage regulators, such as switching DC to DC converters and linear regulators, to power management IC and LED drivers and display solutions. TI's innovative, leading-edge products are a critical success factor to lead and grow in power management. The TPS84620 is an easy-to-use integrated power solution that combines a 6 DC to DC converter with power MOSFETs, an inductor, and passives into a low-profile BQFN package. It allows a compact point-of-load design with greater than 90% efficiency and excellent power dissipation with a thermal impedance of 13 degrees junction to ambient. The integrated step-down solution combines the inductor and passives onto one device and requires only 3 external components, resulting in a complete solution in a space less than 200 millimeters squared. The TPS84620 supports a variety of high-power telecom infrastructure and industrial systems that use DSPs and FPGAs. From the evaluation board, we can see the TPS84620 only needs 3 external components to operate. The resistor is used to adjust the output voltage from 1.2 volts to 5.5 volts. The required input capacitor and output capacitors are used to reduce the reflected ripple current and the input and improve the transient response of the output respectively. Compared to the discrete solution, the integrated solution is much easier to use. However, it didn't decrease the performance. As shown in the chart, the efficiency is up to 95% when the power stage input and the control input are rated for 5 volts. Quad flat pack no leads and small outline no leads are leadless packages with electrical connections made via lands on the bottom side of the component to the surface of the connecting substrate. The QFN or SON has lead fingers exposed on the bottom side of the package. Electrical and mechanical connections between the components and motherboard can be made by soldering the part using screen-printed solder paste and reflowing after placement. The advanced packaging technology affords a robust and reliable power solution compatible with standard QFN mounting and testing techniques. The TPS84620 features excellent thermal performance. It provides 6 amp continuous output current, up to 85 degrees Celsius ambient, with no airflow at both 12 volts and 5 volt inputs. 13 degrees Celsius junction to ambient thermal resistance keeps the device and circuit board cooler for the long-term reliability. The diagram shows 58.9 degrees Celsius maximum package temperature under operating conditions. The device has a built-in thermal shutdown circuitry to force the device to stop switching if the junction temperature exceeds 175 degrees Celsius typically. In this slide we include the list of target applications for the TPS84620 Integrated Power Solutions. TI has dedicated to design 600 mA low power DC-to-DC converters since the year 2000. The direction is towards small solution size and high power density. The TPS8267 is the industry's smallest integrated plug-in power solution at 6.7 mm squared, providing 90 milliamps per square millimeter. The device combines all external components in TI's new microSIP package with a 1 mm height, easing design for 600 mA portable electronics such as smartphones. The TPS82671 operates at a very low 17 microamp quiescent current and achieves power efficiency of greater than 90% from an input voltage of 2.3 volts to 4.8 volts. A unique pulse width modulation frequency feature reduces noise and improves performance in radio frequency sensitive designs. The mode pin selects the operating mode of the device. Connecting the mode pin to ground enables the automatic pulse width modulation and power save mode operation in order to increase efficiency. Pulling the mode pin high forces the converter to operate with a fixed frequency pulse width modulation, allowing simple filtering of the switching frequency for noise-sensitive applications. High efficiency and low quiescent current translates in a longer battery life. Efficiency affects battery life while the device is functional, and quiescent current when the device is in standby. TI has introduced microSIP, the latest innovation in system and package technology integrating IC and passive components in a single device featuring an embedded picostar. The small microSIP footprint provides a standalone power supply platform, driving an unprecedented power-to-package density of 90 milliamps per millimeter squared. microSIP is offered today in an 8-pin format for the TPS8267. For noise-sensitive applications, the TPS82671 has pulse width modulation spread spectrum capability, providing a lower noise regulated output, as well as a low noise at the input. The goal of spread spectrum architecture is to spread out the emitted RF energy over a large frequency range so that any resulting electromagnetic interference is similar to white noise. The end result is a spectrum that is continuous and lower in peak amplitude. The TPS82671 is targeted for most portable electronics such as mobile phones, hearing aids, IP phones, and Bluetooth headsets.